Everyone, this is a pulley problem. In this problem, we have to find out the accelerations of block M1, M2 and this pulley. Let's say this pulley has mass MP. The pulleys are not massless. Okay, we have to find the acceleration of M1, M2 and this pulley. This pulley will obviously will not move because it is attached to this pivot here. Okay, so let's do that. Now, before we talk about this, will the accelerations of m1 and m2 be same? It may or may not, we don't know. So first you see this pulley and this mass m2 are attached together. So if this mass m2 goes by a certain amount x, this pulley will also go down by the same amount x. Okay, so you can see here, if I draw it like this, the pulley is going downwards by the same amount x as the block M2 has gone down. Okay. Now, if this pulley is going down by the x amount, this string here is not moving. It is stationary. You can see it is attached here. So all the 2x, see, this is the x distance, this is the x distance here also. So this total length is 2x, right? So this 2x has to be released from this string, okay, which is passing over this. So this block will come upwards by 2x amount. So if this pulley goes down by x amount, the block m1 will go up by 2x amount. Okay, it is not the same. So the acceleration of block will be 2a if the acceleration of mp is a. And note that acceleration of mp will be same as m2, which is a, because both are moving by the same amount. Okay, now let's draw the free body diagram of masses m1, m2 and mp. First we will talk about m1 mass. So let me draw m1 mass here. Upward force is the tension. Let's call it as T. Okay, so let me draw the tension here. Tension here is upwards capital T. Now this is the same string all over. So here also the tension will be T. Here also will be the tension T. Here there will be downward tension T dash. And here there will be upward tension T dash. Why the T dash tension? Because the string is not the same. It is different. This is a one string. This is another string T dash. Okay. Now T is upward for M1, downwards is M1G, and the block is moving upwards with an acceleration 2a. So I will draw the first equation. I will write the first equation. T minus M1G is equal to M1 times 2a. This is my first equation. Let's draw the same. Let's do the same for this another mass. Let's take this pulley for that matter. This is a pulley. Upward tension is T. Upward tension is T. Downward tension is T dash. Okay. So mass is MP. And of course, mg downward force is also there. We should not forget that. So this is mpg. So now I am assuming m2 is going downwards. So that means mp is also going downwards. So we have T dash plus mpg minus 2t is equal to mp times a. That is the second equation. So you got two equations. Let's write the third equation, that will be for mass m2. For mass m2, let's use different color. Let's use purple color. So this is mass m2. The tension T dash is upwards and m2g force is downwards, and there is no other force. So this is m2g minus T dash is equal to m2a. That is the third equation. Okay. Now we have to eliminate the tensions to get the acceleration in terms of m1, m2, mp and g. So how to eliminate the tensions? You can see from here, if I add these 2 and 3 equation, I can eliminate T dash altogether. So let me add these two equations. You will get mpg. Okay, let me use different color. This will be m2g plus mpg minus 2t is equal to mp plus m2 times a. This is the equation. Now we can multiply this equation by 2, the first equation. So if I multiply by 2, you will get 2t minus 2m1g is equal to 4m1a, right? So from here you can add these two equations. This one equation, let's call this as fourth equation, and this as a fifth equation. If I add this fourth and fifth equation, what I will get is this m2g plus mpg, m2g plus mpg minus 2m1g is equal to 4m1a, 4m1a plus mp plus m2 times a. So here you can get it like this, m2 plus mp minus 2m1 into g divided by, you take this common, 4m1 plus mp plus m2 is equal to a. So this is the acceleration. Now what if the pulley was massless? If the pulley was massless, mp would have been equal to 0. So if that is the case, if pulley is, acceleration a would have become m2 minus 2m1 upon 4m1 plus m2. That would have been the acceleration.